Let me show you something really satisfying. I select a folder. Click Analyze. And instantly I get a full breakdown of everything inside. All subfolders. All files. The total size. And even the biggest file is automatically highlighted. And if I double-click it, it opens right in Windows Explorer. We're building this entire tool today using C# and WinForms. Hi, I'm Andre, and in this video you'll learn how to build a powerful folder size analyzer that scans folders recursively, calculates total sizes, and visualizes everything in a clean tree view. Along the way, you'll learn directory recursion, working with file systems, and how to safely update the UI in modern WinForms. Let's start by setting up the user interface. Open Visual Studio and create a new WinForms project targeting Net 10. On your form, add a button at the top called Select Folder. Next to it, add a text box to display the selected path. Below that, add another button called Analyze. Now add a tree view. This will display our entire folder structure. Add a progress bar under it. And finally, add a label at the bottom to show summary information like total size and file count. I'm already created the full project in the background right now, so you'll be able to see everything directly. But let's take this one step further and speed things up a bit. For this part, I'll quickly create a simple UI. Nothing fancy, just a clean visual example so you can clearly see what we're building. Don't worry too much about design here. The goal is to understand the structure and functionality. So just relax, watch the process, and enjoy the creation. And right after that, we'll jump straight into the coding part and build everything step by step. After the UI is created, we start with the code part. So first we can double-click both buttons and also one special event from the tree view control. So you see direct that the needed code is created by the RIDE. So that is our entry. Now let's walk through the full source code step by step, from top to bottom, so you clearly understand how everything works together. We start with our Form1 class. Inside the constructor, we simply call initialize component. This sets up all controls that we placed on the form in the designer. Next, we define our core data model, the folder item class. This class represents a folder in memory. It stores the full path, the name, the total size, the number of files, and the number of folders. It also contains two lists. One for subfolders, and one for files. This is a very important design decision. Instead of directly writing into the tree view while scanning, we first build a complete structure in memory. This makes our code cleaner, safer, and easier to extend. Next, we have the select button click event. Here we use a folder browser dialog. When the user selects a folder, we simply assign the selected path to the text box. This path will be used as the starting point for our analysis. Now we move to the Analyze button, which is the main entry point of our logic. First, we check if the folder exists. If not, we simply return. Then we clear the tree view and set the progress bar to marquee mode. This gives the user a visual indication that something is happening in the background. We declare two important variables. One to store the largest file, and one to store the root folder structure. Now comes a very important part. We use Task.Run to execute the folder analysis in a background thread. Inside this task, we call our recursive method analyze folder. This keeps the UI responsive while scanning large directories. Once the task is finished, we are back on the UI thread. Now we create the tree view structure using the createNode method and add it to the tree view. Then we expand the root node so the user immediately sees the result. We switch the progress bar back to normal mode. Next, we highlight the largest file. We do this by traversing all tree view nodes and comparing their text with the largest file name. When we find a match, we change the background and foreground color. Then we update the summary label. We display the total number of files, total number of folders, the formatted size, and the full path of the largest file. Next, we look at the format size method. This method converts bytes into a readable format. If the value is below 1 GB, we display it in megabytes. Otherwise, we convert it into gigabytes. This makes the output much more user-friendly. We handle the tree view double-click event. Here we read the path stored in the tag property. If it's a file, we open Windows Explorer and select the file. If it's a folder, we open the folder directly. This makes the tool interactive and very practical. This method converts bytes into a readable format. If the value is below 1 GB, we display it in megabytes. Otherwise, we convert it into gigabytes. This makes the output much more user-friendly. Now we move to highlight largest file. This method recursively loops through all tree nodes. For each node, we check if it starts with the name of the largest file. If it does, we apply a highlight color. Then we call the same method again for all child nodes. This ensures that the entire tree is checked. Next, we have create node. This method is responsible for building the tree view. We create a node for the current folder and include useful information like file count, folder count, and total size. We also store the full path inside the tag property. This is important for later interactions. Then we add all files as child nodes, sorted by size in descending order. After that, we add all subfolders, also sorted by size. And for each subfolder, we call create node again. This is what builds the full hierarchical structure. Now we come to the heart of the application, the analyze folder method. This method is recursive. We start by creating a new folder item and setting its path and name. If the folder name is empty, for example in a root directory, we use the full path instead. Then we process all files in the current folder. For each file, we create a FileInfo object, add it to our list, update the total size, and increase the file count. At the same time, we check if this is the largest file we have seen so far. If it is, we store it. Next, we process all subfolders. For each subfolder, we call analyze folder again. This is the recursive part. The method keeps calling itself until all nested folders are processed. We then add the returned data to our current folder. We accumulate the size, file count, and folder count. And we add 1 to the folder count to include the current subfolder itself. The try-catch block ensures that we skip folders we don't have access to. This prevents the application from crashing. Finally, we return the fully built folder, item. At this point, it contains all data for the current folder, including everything inside it. Here you can now see the full source code that we've created together. Feel free to check it out, reuse it, or integrate it into your own tools. And if you have any questions, just reach out to me in the comments. So, are we ready for a test? Let's run the application. Looks like we've got a small issue here. But don't worry, this is actually a really good learning moment. Take a closer look at this method. You can already spot the problem. The event handler is returning task, which is not correct in WinForms. And the fix is very simple. In WinForms, event handlers always return void. If you want to use async code, you use async void instead of task. So let's fix that quickly. Change the method signature to async void. And that's it. Now let's run the application again. Select a folder. Click Analyze. And there we go. Looks much better now. Everything is working as expected. And that's it for this one. We built a complete folder size analyzer from scratch using C# and WinForms. You learned how to scan folders recursively, calculate sizes, build a clean tree view, and even highlight the biggest file automatically. And on top of that, we handled async operations the right way to keep the UI smooth and responsive. If you enjoyed this, make sure to like and subscribe, and check out the playlist for more practical and satisfying tools like this. Thanks for watching, and I'll see you in the next one.